So today we are looking at Chapter 10, Section 3, Experimental and Theoretical Probability. Essential question is, how can you use relative frequencies to find probabilities? So we're going to kind of break this lesson into two parts, experimental probability and theoretical probability. So our first word is experimental probability, and that is probability that is based on repeated trials of an experiment. So if we see here, we're going to set up our fractions of probability of an event. And the fraction is going to be number of times the event occurs over the total number of trials. Right? And usually we're going to be looking at a graph of some sort with these type of problems. So question 1, it says the bar graph shows the results of rolling a number cube 50 times. What is the experimental probability of rolling an odd number? So instead of just rolling an odd number once, we're going to act like we rolled it 50 times. Okay, and these are all the results that were recorded by that. So I want to know the probability of what happened when we rolled that cube 50 times, and I want to know the probability of rolling an odd number. So the first thing I'm going to look at is the numbered rolls. I'm going to look at my odds, 1, 3, and 5. So if I'm looking at that graph, number 1 was rolled 10 times. I just kind of want to add all these up. 3 was rolled 8 times. And if you notice, I'm just kind of using these lines, and it was rolled 8 times. And a number 5 was rolled. If you see here, this one's in the middle, and if I'm going over, it's in the middle of 10 and 12, so that means that is at 11. So if I add these three up, 10 plus 8 equals 18. I'm just going to break it down. 18 plus 11 is 29. So 29 odds were rolled. So we do want to put that into perspective. So when we're doing this, I want to make sure 29 is my numerator, because that's how often the event occurred. So 29 over, and the number of total trials. Two ways we can do it. One, I could add up all of these totals, or, because that would probably be the longer way, if I look at the problem, it told me the cube was rolled 50 times. So the number of trials was 50. And that is actually my final answer. I have my number of times the event occurred, number of total trials. 29 is a prime number, so it cannot be simplified anymore, and you are done. Let's go down to the next question. Now this one is very similar to things that we did in 10.2 using probability. So we're going to make a prediction using probability. It says it rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? So once again, we have a picture here. This is the April calendar. April has 30 days, and we have to know that because we're going to use that information in our problem. So if it rains 2 out of the last 12 days, when you hear 2 out of 12, we should hopefully be thinking of a fraction. So I can write 2 out of 12 as 2 over 12. And before I even start, I'm going to simplify this to make it a little bit easier on myself. So I can divide both of those by 2, and I get 1/6. Okay, so now let's kind of go back to section 1 or 10.2. I have my probability of 1/6, and I have my number of days is 30. What I'm going to do is use those two numbers, and if we remember, I'm going to be multiplying those together to get my answer. Remember, to make 30 into a fraction, I'm going to put 30 over 1, and I'm going to multiply across. 30 times 1 is 30. 1 times 6 is 6. And I'm left here with a division problem. 30 divided by 6 gives me 5. So in problem 1, I was okay with a fraction. But in question 2, it's asking me, in how many rainy days would you expect in April? So I want to say, I would expect 5 rainy days in April. So we're using the probability from the problem. Okay? We're using the number of days in April to get our correct answer. Now, even if you didn't simplify at the very beginning, so if I started off with 2/12 times 30, we're still going to end up with the same answer. So if you don't want to simplify it first, that's fine. Notice we're still ending up with 560 divided by 12. So there's a couple ways to do these problems, so it's kind of up to you to pick and choose. Let's flip to the back. Our second part of the lesson is theoretical probability. Okay, so when all possible outcomes are equally likely, the theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. This is going to be very similar to probability in 10.2. So here's our fraction, numerator favorable outcomes, denominator possible outcomes. So it says I randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? Okay, so I have these letters over here. First, I need to figure out how many vowels there are because those are the favorable outcomes, because that's what I'm looking for. So I have E, O, and E. So that's 3 vowels. I'm going to write a fraction. Number of possible outcomes is my denominator. Once again, how many letters are there? 1, 2, 3, 4, 5, 6, 7. So the theoretical probability of choosing a vowel, 3/7, and you are done. Time to do your practice problems. Once again, number 1 is very similar to the first example in the video. So you're looking at rolling an odd number, define your denominator, add up all of these numbers. Okay, that's the only way you can get your denominator in this particular type of problem. When you add up those numbers, that's going to show you how many times you rolled that cube. Okay. Then you're going to try to figure out how many odd numbers there are. Once again, you're going to add the odd numbers. Make sure you're answering both of these questions. Number 1 should have a little bit of work here. Number 2 isn't as much work, so make sure you have plenty on number 1. And make sure you try it, as always, to get your 5 points.